Alrighty. So in this lesson, we were talking about how many pairs of shoes that you own. Okay, so for instance, you're going to use the data that is provided for your class period. Since both class periods, the data is a little bit different, I'm just going to use my own data. So with that being said, is number of pairs of shoes a categorical or quantitative variable? Technically, it's a quantitative variable because it's how many pairs of shoes you own. Okay, so if you ever can say like a specific number, and it's describing the amount that you have, then you're good. But let's say, for instance, it was asking you a zip code, then that would not be a quantitative variable. That would be a categorical, because it doesn't make sense to say, hey, how many zip codes do you have? That doesn't make sense, okay? So quantitative means a number. Categorical means a type or like a place, okay? So on number 3, it says enter the data on Stapplet.com. You're going to make a dot plot, stem plot, histogram, and sketch below. So when you open Stapplet, when you open Stapplet, what's going to happen is you're going to have all these different choices. So for this first one, what you're going to do, since we're only talking about one single group, you're going to click on this first one, this one quantitative variable single group. So in here, you're going to type something along the lines of how many pairs of shoes. And then for the data, you're going to type each individual person's the number of shoes that they have. So for instance, if they have 5, 6, 7, 8, 9, 10, 12, 13, 15, 20, and I'm just entering my data that I would pull from a class. 3, and somebody had 30. Okay? Now you're going to hit begin analysis, and this one has a dot plot. Okay? So I'm going to pull that and put it in here. And then the other one that we can do is a stem and leaf or a stem plot, depending on the website that you use. Okay? And you always read this with, this is your first digit on the left-hand side, and then this is your second digit. So this number right here would be 5. That would be another 5. This would be 10. Okay? So we're going to take that. I'm going to go drop it over here. And then it also wants us to do a histogram sketch. Okay? So we're going to go back over here, and we're going to drop down histogram. Okay? And we'll take that, and we'll drop it in. Whenever you do these, you want to make sure that you include the titles or the axes. So for instance, this should say frequency right here. I just cut it off earlier. But you want to make sure that you're including that in your final answer. Make this small so we can see everything. Fantastic. All right. So then on number 4, it says describe the distribution of the number of pairs of shoes for your class. So when I ask for shape, it's talking about, is it skewed left or right? So is it skewed? Is it symmetric? Etc. Okay? And in this data in particular, let's look at it. So in this data, I would say that this is kind of skewed right. Okay, so like if I shoot my little line, we got this like tail going way over here. I would say that this is skewed right. So if you don't remember skewed right or left and which one it is, if it has a tail, that means that like if it has a number that's like way out over here, then it's going to be skewed right because that's where the tail ends up. So this would be skewed right. All right, and outliers. So outliers are really numbers that like don't go along. I think in one of the class periods, one person said 0 and then another person said like 110. Those would be outliers because they don't really go along with the rest of the data. Okay. For this one in particular, we don't really have a whole lot of outliers. Technically 30 might be considered an outlier, but in this next lesson, we're actually going to talk about how to solve for that. But for right now, we're just going to say 30 is roughly an outlier. And it may depend on your different data. When it asks for center, it's talking about mean, median. Okay. And so in order to find the mean, you're finding the average of those numbers. So if we go back to our data and we add all of them up and then divide by how many there are, then you'll find the mean. And then if you want to find the median, you're going to cross out your number from lowest to highest, ordering them from lowest to highest. And then you're going to cross off one from the top and bottom until you find the actual true middle. So I'm going to go ahead and find the median because that's really easy. 2, 2, 3, 3, 1, 1, 1. So it's in between 12 and 13, so that would be about 12.5. So my median is 12.5. And then for my mean, I'm going to add them all up and then divide by how many numbers there are. So I'm going to go into my calculator and I'm going to say 5 plus 5 plus 6 plus 7 plus 8 plus 8 plus 9 plus 10 plus 10 plus 12 plus 13 plus 15 plus 15 plus 15 plus 20, 20, 20, 20, 23 plus 30. And then we're going to divide by how many there are. So we're going to divide by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 20. There are 20 numbers. So that's going to be 13.55. Most of the time, these numbers should be roughly about the same. Roughly. With variability, we're talking about the range. We're also talking about the IQR. And we're talking about the standard deviation. Okay? And you should already know how to do these, but again, we're going to talk about those kind of in the next section. So we'll talk about these a little bit more later. Which of these 3 types of display do you prefer and why? Okay. I personally like the either dot plot or histogram, but that's just because I've been using it a lot more. But you're going to list off the advantages and disadvantages of each and every different types of display. So for instance, so an advantage of dot plot is easy to read because every dot represents one person. But one disadvantage is when you have to do calculations. It takes a little bit longer to see all of that. Okay, like for instance, if I'm looking at the dot plot, I have to go, okay, well there are 5 10s and there are, etc., 20s. So it just takes a little bit longer to get all those numbers pulled. Okay, some advantages of a stem plot. You kind of can see where your data falls. Like your data falls in between these numbers or this range of numbers. One disadvantage is if you have more than like one group of numbers to compare to. It's not really like reading friendly. For a histogram, again, it's pretty easy to read. Some disadvantages is, let's look at our histogram. Some disadvantages are it doesn't like really give you a good idea of like spread or shape, because if I do this, sometimes it might mess up. Maybe the outliers aren't obviously like represented, so it just kind of depends. So on number 6, it says, how do the numbers of pairs of shoes for females and males compare? Start by separating the data. So what you're going to do is you're going to look at your data for females versus males. And when you do that, you're going to put it into Stapplet.com. But this time, you're going to use one quantitative variable, but multiple groups. Okay, so again, variable name is how many shoes. Okay, and then for group 1, you're going to be male. Group 2, you're going to be female. And then you're going to insert your data. Okay, so you're going to list out how many girls had this many shoes and how many boys had this many shoes. So I'm just going to throw in some numbers so that you can kind of see that data. Again, make sure that you do it in male, female breakdown. And then you're going to make a dot plot, side by side stem plot, and then histogram. So then you're going to copy those below. So again, this is what it's going to look like. So 10, 5, 5, 5, 6, 8, 7, 13, and 6. And then for females, 12, 10, 5, 10, 11, 13, 15, 20, and 3. Okay. I'm going to begin analysis. And again, there's my dot plot, my histogram. Okay, and on this histogram, got that female, got kind of like a normal distribution on that one. Okay, and then you also got stem plot. Okay, so notice how this is a little funky setup. So remember, this is going to be your first digit, right? So 0, 3. Okay, and we can see that in our data that we had up here. And then 1, 0, so that would be 10, right? And then for the male side, remember, we're going to have, this is our first number. This middle column is the first number. And I know that's a little funky to read, so just make sure, be mindful of that. It even gives me the summary statistics down here. So SD stands for standard deviation, and then Q1 and Q3, hopefully you know what those are, and min and max, and then the median. So these are kind of helpful, and then you don't have to calculate them that way. So to compare these, what I would say for like number 9 is I would talk about shape, outlier, center, and variability. So for instance, I would maybe use like a histogram or a dot plot. So for instance, actually let's use a dot plot, make it easier on ourselves. Okay. So for dot plot, we can see that the shape for the males, it's going to be skewed right. Okay, because we got most of our boys who are down here, they've got like less than 10 pairs of shoes. And we got this one dude who's got 13 pairs of shoes, so it's going to be kind of skewed right. For females, it's kind of normally distributed, except maybe 20 might be an outlier. And we're going to figure out how to calculate outliers a little bit later. But depending on your data, you may or may not have an outlier. Now, if somebody is no shoes or they have 100 shoes, then that's something to keep in mind. But right now, this should just be normally distributed. So the last thing I really kind of want to talk about is when you describe the data. You definitely need to make sure that you use LY words. So what I mean by that is skewed slightly to the right. Okay, and we use these LY words because it helps us not say absolute, this is what it is. Data is relative. Okay, so it's not going to just constantly be on the normal distribution curve. Okay, so it's just something to keep in mind. And when you compare, you need to make sure that you always use greater than or less than. Okay, greater than or less than. So that's just something to keep in mind when you're comparing data. Make sure that you're using comparison words. That's really, really important.